Radical equations are any type of equation that uses this symbol here, the square root, or also known as the radical. Now, there are other types of roots. There are also cube roots, one has a little 3 right here, and fourth roots, one has a 4, and so on and so forth. But we're going to stick with square roots today. The big idea behind square roots are they're kind of the opposite of squaring something, which what is squaring something? If I say 5 squared, that's the same thing as 5 times 5, which is just 25, right? Likewise, let's say I asked my way to work yourself backwards. Let's say I said, how can you write 36? Well, you can write it as 6 times 6, which should be the same thing as 6 squared. These are all perfect squares right here. 25, 36, 49, 81, 100. They're perfect squares. They're a number that you can break up into two of the same thing, right? So for example, if I asked you to square root of 49, that's what it's basically asking you, is what breaks down into two of the same thing. So square root of 49 is just 7. So square root of 36 is just 6. Square root of 25 is just 5. That's what square roots are. Big deal is that the square root and the square are opposites of each other, okay? So knowing that, we can actually solve square root equations, pretty easily. So let's start off with a bit of a basic one to kind of get your thoughts boiling. So 6 equals square root of v minus 2. Again, the v is just a letter. It's a variable that represents some mystery number we don't know. So 6 is equal to the square root of something, take away 2, okay? So now, how do we get rid of a square root? We get rid of it. Remember I said the square and the square root are opposite of each other. So we raise everything to the second power. So I do to the second power here, to the second power here, and that just goes away. Boom, boom. So I'm just left with, on the right side, v minus 2. And we've solved this thing on this right side before. Now, 6 squared, 6 times 6 is what? Because remember, that's what we know 6 squared is. We know it's already 36, right? And then it turns into an equation that we know and love, right? So all we have to do is add 2 to both sides. So that would end up being 38 over here is equal to my v. So I'm a missing number. The v is indeed 38. Now, we always check our answers too to make sure they work, because sometimes they don't always work right. So I'm off this side in yellow, or green, or whatever color this is. I'm going to go ahead and plug in 38 just to make sure it works. So I'm going to check my answer. So I'm going to do 6 equals square root of my v, which is 38. Put that in parentheses. Take away 2. 38 minus 2 is indeed 36. And the square root of 36, remember we talked about that before. Square root of 36, what makes 36 a perfect square? Well, 6, right? 6 and 6 are indeed the same number. So that means this 38 does indeed work. It's a solution to this square root equation, okay? Let's do something slightly more complex where we have a little bit of work to do outside beforehand, okay? Negative 10 square root of v minus 10 equals negative 60. Now this one we have something outside the square root, so we're not going to square just yet. Some people do square right off the bat, but then you actually have to raise this to the second power as well, and then sometimes it gets a little tricky, especially if things being added on the outside. So I always say, just like how you get one part by itself first, we're going to get the square root part by itself first. So how do I do that? Well, I have to get rid of the 10, the negative 10. Now, whenever things are smushed together, remember they're being multiplied. So this times this. How do I get rid of multiplying? Well, I divide. So let's divide both sides by negative 10, there and there. So this will be 6 over here. And then look at there. Now we have our v minus 10, our square root of v minus 10, by itself. And this one actually kind of looks kind of similar to the other one. So again, how do I get rid of square root? Well, up here I squared it. Doesn't matter what side it's on, really. We're just going to square both sides. So that goes away, that goes away. So that means v minus 10 equals 6 squared is 36. And we just add 10 to both sides. And that means v equals 46. I'm not going to bother going back and checking this one, but always go back and check your answers when you can. All you're doing is plugging it back into there and seeing how it works, okay? Let's do one where we have square roots on both sides. Now, big thing is, how do I get rid of a square root again? We get rid of a square root by using that symbol right there, by raising everything to the second power. What happens when we do that? Well, the square roots just go away. The cool part about when you have square roots on both sides is you really don't have to do a lot of work to it. Once you square both sides, all the square roots just kind of cancel out and everything just goes away. So when that happens, it turns into a really basic equation, kind of like we've been seeing so far. So if I have something like square root of 3m plus 12 equals square root of n plus 8. Now you may say, oh my gosh, there's 2 square roots. How do I deal with that? Well, we can deal with it. Same we've been doing it. We get rid of it by squaring both sides. Square it there, square it there. That goes away, that goes away, that goes away, that goes away. So then I'm just left with, easily enough, an equation, a multi-step equation that we've seen many times before. So all we got to do is just move everything to one side. And again, the best part about this is the fact that everything kind of just turns into the same type of problem. That's the lovely part about these equations, is everything turns into the same thing we've been doing before. Hopefully, if I'm moving too fast through this, please tell me. Divide by 2 on both sides, and it's equal to a negative 2. Now, I'm actually going to check this. Why am I going to check this? Because I know it's not going to work, okay? And that's okay for things not to work sometimes. So, actually, I have to believe it will. I'm sorry, I was thinking incorrectly about that, but I still want to check it to prove my point here. So, let's say I plug this in to both sides. I'm going to do square root of 3, negative 2 plus 1. I, for a moment there, thought I was going to have a negative as an answer, and you can't have negatives instead of square roots because that can never work. I'm going to put the word check up above here just so I can make sure I know I'm checking my work. That's what this mess is. So, again, I'm going to figure out what this is. 3 times negative 2 is negative 6, plus 12 is positive 6. So, equals negative 2 plus 8 is 6. Now you can figure out, you can type in your calculator square root of 6, but I mean either way, look, left and right side are the same, so that means negative 2 is indeed an answer. Now remember how I said that sometimes you'll have make sure you check your answer because some of those things won't work. The good part about this is a lot of times will, but sometimes it won't. And if you have a negative inside of a square root, like I thought was going to happen for a second there, then that means your answer is not going to work. That means there's no solution, which sometimes does happen, but that's a kind of a rare scenario, but it does happen nonetheless. That's how you do square roots. You just square both sides and you just work out the math from there like we've always solved a basic equation.